For section 2.4, we're going to talk about some interpretations of the derivative, really some ways to put this derivative in context, give it some meaning. So far we've used the notation f prime of x to mean the derivative of the function. But I want to give you another set of notations, and that's what we're talking about today. So the derivative of a function we say was like the slope of the tangent line at a particular point. And so if I were to pick up an x value like 2 and there's a point there, then the derivative f prime of 2, the slope here would be f prime of 2, the slope of the tangent line. Now there's some other notation, and the other notation for this derivative is dy over dx, or some people just say dy dx. And the reason why that's there is it's like a small change in y over a small change in x. So for the slope of that, the small change in the d is sort of like the Greek letter delta, and so we're thinking of a change in, like delta is used in science for a change in y over a change in x. And that's going to be really helpful to us as we make this interpretations for meanings there. The problem is this is a little more complicated for evaluating at a particular point. It looks like that, and I don't like to use this thing in red to evaluate. I prefer f prime of 2 for that. Never mind that, we could look at some different technologies. If you have a Texas Instruments calculator, it might use the dy dx. If you have Desmos, sometimes it uses that, and sometimes it doesn't. So let's take a look at how we can use this, how we can apply this, these ideas. So let's say that we've got a function f of x, and it's the height of an object. Actually, I don't want to say f of x, I want to say f of t. F of t is the height of an object, and I'm going to use the variable s to say, like, the distance is a function of time. So I'm going to say s is measured in feet, and t is measured in seconds. So if we have this set up here, the derivative of this function is f prime of t, and in terms of this d notation, it's a small change in the output, which is s, divided by a small change in the input, which is t. So let me just rewrite ds over dt and say that's a small change in the output, which is height, over a small change in the input, which is time. Therefore, the units of the derivative will be the same as the units of a small change in height, which in this case is feet, over a small change in time, which is seconds. One way we say this is feet per second, which sounds like a unit of velocity, which it is. And that's because the derivative of the distance function is a velocity. So that's how we can use this change in height over change in time to help us with this. Let's say that we wanted to put this in an equation and then interpret it. You say, why we want to do that? Because I'm going to ask you to do that in a moment. So let's go ahead and say we have a statement that says f prime of 4 equals negative 20. And we want to know, what does that mean? And to figure out what that means, we need to figure out what the units of the 4 and the negative 20 are. And so in this case, that 4 is the input, and in f prime of t, t was time, and so that 4 means 4 seconds. That negative 20 is talking about, it's equal to a derivative. So that's negative 20, we look back up to these units, and that's negative 20 feet per second. Since it's down, since it's negative, I'm going to think that that must mean we're moving down, since it was the height of an object. And so these three things are valid interpretations of f prime of 4 equals negative 20. All three of these are three slightly different ways to say this. At t equals 4 seconds, the velocity of the object is negative 20 feet per second. That's one way to say that. Another way to interpret f prime of 4 equals 20 is to say at t equals 4 seconds, the object is moving down at 20 feet per second. That seems almost the same, but notice here I'm saying moving down at 20 feet per second. In the first one I said negative 20, so that negative I'm turning into a phrase moving down. And a third way to interpret this is to say at t equals 4 seconds, the object will move down approximately 20 feet over the next second. I'm saying approximately because I know I can't be exact. I'm not sure I can be exact on that, but I'm saying in the next 1 second, because this is talking about negative 20 feet per second, this negative 20 feet per second could be thought of going negative 20 feet or down 20 feet in 1 second. So that's that third interpretation. I'd like you to try exercise 2.16, and then we'll continue